place that she's living in, and it's just lovely.
That is great. Okay, we're going to run this little video.
On April 8th, 2024, portions of the United States will get to enjoy the sight of a total solar eclipse. The last time this took place was back in August of 2017, so this is a good time to refresh our memory as to what's going to happen, why it occurs, and let you know where you can watch the show in the sky. A solar eclipse occurs when the moon moves between the Earth and the sun, blocks the sun's light, and casts a shadow on the Earth. When the moon completely covers the bright disk of the sun, that's a total solar eclipse. This differs from a lunar eclipse, where the moon moves behind the Earth, so it's now the Earth blocking the sun's light on the moon, creating a shadow on it with a red tint. To remember the difference, just remember what object gets darker. With a solar eclipse, it's the sun, and during a lunar eclipse, it's the moon. Because the moon's shadow is relatively small, a total solar eclipse is a pretty rare event to see. In order to do so, you have to be on the sunny side of the planet and within the path of the moon's shadow. And that path is affected by the Earth's rotation, moon's orbit, and where they are in their orbit around the sun. There are a lot of moving parts that go into creating this incredible sight. And speaking of parts, during a solar eclipse, the moon is actually casting a shadow consisting of two parts, the umbra and penumbra. The moon's umbra is the part of the moon's shadow where the entire sun is blocked by the moon. In space, it's a cone extending about 232,000 miles behind the moon. It's when the small end of this cone hits the Earth that a total solar eclipse can be seen. Those factors are why only a limited number of locations on Earth get to actually see it. So, if you find your area in the path of totality this year, treasure the sight, because on average, that same spot on Earth won't see another total solar eclipse for 375 years. The area around Carbondale, Illinois, however, has hit the cosmic jackpot, getting to experience this year's eclipse, as well as the one from 2017. But their next view of a total solar eclipse won't happen until the year 2343. When you check out an eclipse map that depicts the path of totality, keep this in mind. While many maps will show a circle representing the moon's shadow, the true shape of the umbra is more like an irregular polygon with slightly curved edges. This is due to the fact that the moon isn't a smooth sphere. It has mountains, valleys, and craters on its surface, all of which affect the passing sunlight and shape of the resulting shadow. NASA's Lunar Reconnaissance Orbiter spacecraft, which has been orbiting the moon since 2009, has provided scientists with incredibly detailed photographs, terrain maps, and other sets of data that have allowed us to better understand the shape of the moon's surface. This, in turn, has given us the ability to create more finely detailed maps depicting which specific areas on Earth lie within a solar eclipse's path of totality. Regions outside the narrow path, depending on their distance from it, will get to witness a partial eclipse to varying degrees. As you can see, the penumbra shadow passes over almost all of North and Central America, as well as Greenland, Iceland, and the Western British Isles. This 2024 total solar eclipse is therefore giving millions of people the opportunity to share in this rare and dynamic interaction between our Earth, Sun, and Moon. On April 8th, 2024,
The Gabbert Solar Patrol program is a heliophysics program aimed at citizen scientists and K-12 students, both locally, nationally, and throughout the world. The goal of Gabbert Solar Patrol is to monitor active regions on the sun in order to understand how they're connected to explosive events that we categorize under space weather. Participants can remote in and actually control the telescope themselves. So a common observing mode with the Gabbert Solar Patrol is that we'll have classrooms actually operate the telescope themselves, collect some data, and then generate maps of what the sun looks like at radio frequencies. They're gaining a really unique experience that I think is really special to the Gabbert program. And that's the ability to walk through the scientific process from the very beginning, from the steps of collecting the data themselves, all the way to reducing that data and interpreting scientific results from their studies. I get excited anytime I get to operate a radio telescope, and so I really enjoy it when other people get to have that same opportunity and that same learning process.
Hello, everyone. This is Scott Roberts from Explore Scientific and the Explore Alliance, and welcome to the 144th Global Star Party. I'm here with David Levy, who is trying to get focused in here from his place out in California. And David, are you with us?
Yes, I am.
Okay, here we go. There we go.
Yeah.
Anyhow, it's the theme tonight is detection, and this is something that thrills every astronomer when they find that elusive object they've been going after. And some of these detections, of course, involve just straight up discoveries, and David is currently spending some time with Gene Mueller, who's made well over 100 detections of supernova, asteroids, comets, and then, of course, David himself has made so many discoveries of comets and asteroids as well. I think he's probably got a couple of supernova under his belt as well. So, but David, thanks for coming on and doing this with me and spending. I know that you're supposed to be spending time with Gene right now, but thanks for logging in from California.
Well, thank you. Can you all hear me?
Yes.
You couldn't have chosen a better theme than detections for this week, because I have here Jean Mueller at her home in just north of San Diego. And we're just having a wonderful catch-up visit. Jean Mueller is one of the most famous and well-known astronomers in the world.
That's
Jean
right.
has discovered 107 supernovae, or detected, as the theme of today is.
And I'll
107
add one of the
times.
nicest people in the world too. So,
And she's one of the nicest people in the world, and one of my very best friends, my friend for life.
that's right.
And I really so wish there was a way we could get her out to see the eclipse, but in absence of that, I'm having a lovely, lovely visit with her. My quotation today, I also have to do from memory because I left my book of quotations at home. And so what I am going to do is to quote my favorite one of all of the quotations, and that is Gerard Manley Hopkins. Those of you who have studied, oh yeah, we have another visitor today, and that is Jean's cat, who is here, and he may well want to eat this telephone if he doesn't like what I'm saying. But for those of us who have taken Gerard Manley Hopkins in high school or in college, one of the most boring poets you can imagine. He has the rhyme scheme that is so difficult that you can't even follow it. It's and his poems are almost impossible to interpret, very, very difficult. And the best part of doing Hopkins is when you go to another poet. Except when Gerard Manley Hopkins was an undergraduate student at Balliol College at Oxford in England. And while he was an undergraduate, he wrote a poem about a comet. And it has so much heart and so much soul to it. I wanted to share it with you today. I am like a slip of comet, scarce worth discovery. In some corners seen bridging the slender difference of two stars, come out of space or suddenly engendered by heady elements, for no man knows. But when she sights and spins her skirts out, while her central star shakes its cocooning mists, and so she comes to fields of light, millions of traveling rays pierce her. She fangs upon the flame-cased sun, which today, by the way, has a big group of very active spots just coming on. A group that's almost the size of Jupiter, and it's going to be a big one. Uh, but that's not part of the poem. Millions of traveling racehorses for flanky sun, and sets the sun's light as full as Gideon's fleece. But then her tether calls her. She falls off, and as she dwindles, sheds her smock of gold amidst the sistering planets, and then goes out into the cavernous dark. So I go out, my little suite is done. I have drawn heat from this contagious sun. Through not ungentle death, now forth I run. I'm feeling that the dedication to Jean of this global star party of detections, especially in honor of the master detector of 107 supernovae, comets, asteroids, and a love of the night sky that is second to none. And thank you all very much for allowing me to share this time with you.
Thank you so much, David. That's wonderful. And again, happy birthday to you, Gene Mueller. I know that you're back there. And David, thanks for coming in at this time. So,
Thank
all
you.
right. Okay, so that's wonderful. We are our schedule's a little mixed up at this point, but I think what we're going to do is we're going to bring John Goss on. John Goss is with the Astronomical League, and his talk is about Mercury. So, John, you're up next here.
Well, thank you. Thank you, Scott.
Thank you. Thank you.
Thanks for having me on. I mean, this is certainly a privilege for me to get up here and talk about stuff that makes it sound like I know what I'm talking about, but we'll see how that
But
goes.
you do know what you're talking about.
Well, so sort of, with the whole idea of detection, that's kind of what it's about. And we all want to see things. In fact, we all see them in different ways. And that's how I'm going to start out with my little talk here. A number of years ago, my wife and I were listening to the radio while we were leaving a major U.S. city. And on the radio was a report, a night sky report by a local amateur astronomer. And you know how these things go. They talk about, these are certain planets you can see, right after sunset, you'll see Jupiter high in the west or high in the east, wherever. You'll see Saturn, the moon's going to be up, that type of stuff. So there he was talking about it, and he said, and before I forget, that bright object you see next to the western horizon is Mercury. And I started thinking, no, wait a minute here. I was kind of following Mercury out of another interest. And I knew that Mercury was not going to be a bright object low in the west. It was going to be there, yes, but it was going to look fairly dim. So my wife and I were talking back and forth about this. Well, I better check up to make sure that I'm not in error here. So when we finally get home, I looked at my records and notes and all this, and I could see that that we were both right, in a sense. You see, what the report was talking about was the published magnitude of Mercury was going to be fairly bright. Was going to be, let's say, 0.5 magnitude. Now, for those of you who are unfamiliar with how magnitudes are, well, this is about equal to the bright star Procyon, favored in the winter sky, and it's easy to see. It's one of the brighter stars. So yeah, you could say it was a bright object. But since Mercury, even though it was about as bright as Procyon, it was sitting fairly low in the west right after sunset. So that means it was sitting in the brightest portion of the twilight. And you have a 0.5 magnitude object in the bright twilight, it makes it tough to see, really, really hard to see. You have to know exactly where you're looking. And if it gets any dimmer than that, you just can't do it. So I'm going to turn on my slides here, I hope. Show you how that goes. So we found this, excuse me. So as I said, we found Mercury in the west, but I found it as being rather dim, and you really had a hard time seeing it. Although the published values indicated it being 0.5, maybe not even quite as bright as 0.5, but certainly that is easy enough to see. So I was did some studies over the next few weeks of Mercury. In fact, even longer than that, over many different apparitions, many passings of the planet. So I get this down right. I wanted to see how well you could see Mercury under these published brightness magnitudes. And what I found out after many observations, I was measuring it after so many minutes after sunset, after the sun has dropped so far below the horizon, that measuring Mercury, how far it was above the horizon and its published magnitude. And this is what I came to conclude, that if you have a little to no haze near the horizon, if you wait until 40 minutes after sunset, the sun will be about 8 degrees below the horizon. If Mercury is 8 degrees or higher above the horizon, and if its magnitude is brighter. Now, I kind of messed this statement up, but if the magnitude of Mercury is brighter than 0.5, you ought to be able to see it. But if it's less than 0.5, you won't be able to see it. And this is after many different observations I made. Now back up again, I can say 30 minutes after sunset. If the sun would be about 6 degrees below the horizon. And if Mercury is 6 degrees or higher above the horizon, if Mercury is brighter than 0 magnitude, which as you know is that'd be a fairly bright star if it was a star, you can see it. So this is from my own direct observations. And I put things together in a chart here for you. Oh, before I move on to that, I also came to the conclusion that it really helps that if Mercury is positioned somewhat above the ecliptic, this would put it better viewing for Northern Hemisphere viewings in the springtime, which is where we're at now. It would help even more if Mercury was near aphelion, but that really only occurs for viewers in the Southern Hemisphere in their spring sky. This year, I think that's going to be sometime in November. But anyway, be that as it may. Put all this information together, what I was just saying, and I came up with a chart like this. And I threw in the dates for this spring. This is one reason why I really wanted to be on the Global Star Party tonight, is because this whole Mercury apparition begins right now, even though you won't be able to see it tonight. A few weeks ago, February 28th, Mercury was superior conjunction, meaning that it was behind the sun from where we are on Earth. So obviously you can't see it. But over the next week and a half or so, it swings out from the sun. And yes, you might be able to see it if you knew exactly where to look. And if you had binoculars, you'd be able to pick it out in the low twilight, this low bright twilight. That'd be 1 to 2 weeks after superior conjunction. Now, Mercury at that point in its orbit, appears as a small, pretty fat gibbous phase. And that's good because the gibbous phase reflects a lot more sunlight than a crescent phase. So some of the published magnitudes are going to be listing Mercury as being like minus 0.5 or so, pretty bright. And so that's why you might be able to see it in the twilight, in the low twilight. Let's move on a little bit. So then 3 weeks after the conjunction, which is kind of where we're going to be at next week, Mercury is still in the gibbous phase, but it's a thinning gibbous. It's not really quite as bright, but now it's higher in the darker part of the twilight, and you'll be able to see it really easily. And that's the time when people really look at it, really notice it, is when it's about 3 weeks after superior conjunction. Then about 4 weeks after superior conjunction on March 24th, remember, it was behind the sun on February 28th. So 4 weeks later, on about March 24th, it's as far as it's going to get from the sun angle-wise. And it's still fairly easy to spot. But then as it swings closer to us, as it starts coming between us and the sun, it gets into that crescent phase, which doesn't reflect as much light as that gibbous, and it dims significantly, even though it's still fairly high in the evening twilight. It dims significantly and it's tough to see. This year, the greatest eastern elongation is on March 24th. 3, 4, 5 days later, it'll be tough to see. All of a sudden, it'll be like it's gone. And its magnitude will have dropped. Whereas at greatest elongation, it may be like a 0 magnitude, somewhere in there. But now, 4 days later, it's dimmer than a 0.5 magnitude, and it's tough to see. It's dropping back into the bright evening twilight. See a little bit better here on how you can see compare the two and where Mercury actually is in its orbit. We can start out at position number 1 on the chart to your right. Mercury's behind the sun as viewed from the Earth on February 28th. Well, as Earth orbits the sun, well, so does Mercury a lot faster, and it starts catching up. So when it's in that bright gibbous phase, is in this green section here, that would be around March 15th or so. And then on March 24th, Earth be there, Mercury there, and it'd be the widest angle from the sun. Then after that, the angle between the sun and Mercury decreases quickly, substantially, and it starts to dim rather dramatically. So it's tough to see. So how I started out with this whole talk was my, the car ride, listening to the report and where Mercury was. Well, at that point, in that situation, Mercury was low in the sky, position low in the sky, but it was still fairly bright because it was that gibbous phase, but it was in that bright evening twilight, so it was tough to see. So in a sense, we were both right. I said it couldn't be seen easily. Now, that's true because it was in the bright twilight, but he said it was a bright object in the sky, and that could be construed as being true because it was that bright gibbous phase. Something to think about there. You know, we see things in different ways and report them in different ways. But when you look into it, you find more about this. If you talk about detecting Mercury for the first time and how long that you can see it in the sky to detect it, well, this helps explain some of that and what's going on. Okay. I just tossed in there to talk about the southern hemisphere because I don't want to leave them out because this is the global star party. Unfortunately for them, right now, the angle of the ecliptic with the horizon is fairly low, so Mercury will not be rising very high in the sky. On March 24th, well, it's nice and high for us here in the northern hemisphere. Southern hemisphere, no, it's low. This is a horrible time to look at it. But they got us beat this coming November. Mercury will be much higher in the sky than what we're going to see this March here in the northern hemisphere. They got us beat. In January 8th of this year, we had a really good sight in the morning sky in the east. Excuse me. We had the crescent moon, very, very pretty, hovering right next to red Antares. Now, how do you like this? This phone of mine that I captured this picture really pulled out the red. Antares isn't quite that red in the sky, but you have the bright moon next to Antares, and then to their upper left was very bright Venus. And to the upper right, you can see the 3 stars of the claws of Scorpius. Pretty amazing. And that's what a lot of people were looking at. But if you would look closer at this, spend some time and then looking in the sky, you would have seen a very bright object low in the east or southeast, just above that bank of clouds. That is Mercury. And that was about middle brightness that it's going to achieve, at least for this run around the sun. But as you can see, if it would have been lost a little bit lower in the sky, it would have been bumping into those clouds, and we wouldn't have been able to see it. So to see the planet, see it well, you got to have a nice clear skies, a fairly low horizon. There's no hills, mountains, trees in the way, and then you might be able to see it if the conditions are just right. Now I'm going to leave you with this. So thank you for listening to this. Over this next few weeks, go out and see if you can find the planet, especially after March 15th or so, the 20th. That's a great time to go out and see if you can find Mercury. And when you do, you're going to be thinking, what's all this hullabaloo about? of course I could see it. It's so obvious. But come back a week and a half later and it'll be gone or nearly so, and you'll know what we're all talking about. So thank you for that, Scott. Thanks for letting me present something like this. It's all a matter of detection of your own personal experience with your own eyes.
Right, right. How many times have you seen Mercury?
Well, in a way, I kind of make it a little game because it comes around the sun so often. It's here for a few weeks and then it's gone, and you don't see it for a while, and then boom, it's back again, and all this. So if I'm at a star party or if I'm out just observing by myself, I'll make
Point of
a special point to find it.
yeah.
So
Uh, Being absolutely honest, I've only seen it like 3 times myself.
well,
So, um,
I
but
think a lot of people really haven't seen it. Because you have to be in the right place at the right time in the sky
right.
conditions. And then, as I said, you'll be thinking, what's the big deal? It's easy to see. Well,
Yeah,
not
what's a
really.
pleasure though is that you always see it in phase, so
Hmm. Hmm.
um, and it's beautiful, and it's to me you just get a special feeling knowing that you're looking at the first planet in our solar
Hmm.
system. So,
Hmm. And the smallest
yes,
planet too.
that's right. That's right.
Well, thank you, Scott.
Thank you so much, John. Take care.
Yeah.
Okay, well, up next, we are going to be talking with Dr. Ariel Grabowski. She is involved with Unistellar's citizen science program, and she's going to give us an update about that. But she also is I think, a postdoc at the SETI, the Search for Extraterrestrial Intelligence program out there in California. So, it's always exciting to hear from someone that's working with those projects. But I think her specialty and what she's concentrated on right now is comets. Is that right?
That's right. Yes.
Great, great. Well, thanks for coming on to Global Star Party and informing us of Unistellar's Citizen Science Program. We like to get updates about that. Unistellar has really, I think, out of all the people, including ourselves, we don't. The telescope manufacturers typically don't have a formalized citizen science program. There's citizen science done with all of our telescopes, but I think only Unistellar has this program, and it's very special. So, what is your role there, Ariel?
Yeah. It's been really fun working with them for that reason. It's a really unique program that they have going on. And so for them, I specifically run their Comet program. There are several programs that they have, but I decide what comets we're going to look at and that we're going to prioritize and stuff like that.
Okay. All right. Well, I'll let you take it away. Thanks for coming on.
Yeah. Okay, let's see. Let's share my screen here. Here we go. Okay, yeah. So again, I'm Ariel Graykowski. I am a postdoc at the SETI Institute, and I also am an astronomer with Unistellar. And today I'm going to talk specifically about my work with the COMET program in Unistellar and the citizen science that we do. So just briefly, for those who haven't heard of Unistellar at all, they are a French company that makes these smart telescopes called evoscopes that you control with an app on your phone. The point is it's supposed to be really easy to use. And if you have one of these evoscopes, then you can participate in citizen science. And so we have several programs, Comets, the one I run, but my colleagues also run the transient program, which is like supernova, exoplanets, occultations, and planetary defense. So there's a lot of different ways to get involved if you have one of these scopes at Unistellar. And it's been really fun so far. There's over 10,000 evoscopes across the world, everywhere around the world at this point. Something we like to say a lot is the sun never sets on Unistellar. And that's a really powerful tool for science. Because we always have somebody who can look at the sky if anything happens. It's interesting. If it's daytime where I am, I'll message somebody on the other side of the world and say, hey, can you take a look at such and such object? And so that's been a really amazing tool. And so here I just have kind of a map of about where the telescopes are located and the different models of EV scopes that exist, which you can take a look at more closely on their website. But right now, I just want to talk mostly about the citizen science we've done in the COMET program specifically. And so our goal with the COMET program is kind of twofold. Our main primary goal is to monitor comets over time. Now, the reason we want to do this is because comets are always changing. They have these iconic coma and tails, that is what you might think of when you think of a comet. And those are getting brighter and they're becoming more active as a comet gets closer to the sun. And then conversely, as it gets farther from the sun, this activity can fade. And it's largely due to it being heated up by the heat of the sun, of course. And so we have a really great tool, the Unistellar Network, to do this monitoring and to monitor a lot. So over the course of a week, we could get a lot of measurements, but also over a long period of time. So some of our goals with Unistellar is to sort of automate this process where we take that monitoring and we predict what's going to happen next. And we want to be able to do it for all different kinds of comets, faint and bright. And we want to monitor them for as long as we possibly can. That's going to really help us with the prediction. And so it's important that we can detect comets at their faintest possible point in their orbit. And so that's something that we've recently been able to define. And so I'll share a bit of that. But we also are really well equipped to identify something surprising that happens in the sky. So if a comet outbursts, for example, which is when it gets really bright all of a sudden, that is an inherently serendipitous process. We just hope to catch it, right? And so our network has been really, really good at following up with outbursts whenever they're reported by the astronomy community. And that's been really great. But now we want to be able to do this even faster and monitor more and automate this monitoring and detection process so Unistellar can be amongst the first to discover an outburst and share it with the community instead of just following up. And so we've done a lot and we're making a lot of strides in this detection department. And in particular, I'm going to talk about one comet that's coming up to be a very exciting one this fall, and that's comet C2023A3 Tsuchinshan Atlas. Excuse me if I did not pronounce that correctly. But this comet is exciting because it's going to be a naked eye comet in the fall. And basically, when this comet was discovered, which was January of last year, it was very, very faint. It's actually still pretty faint, but it was very faint, and our EV scopes weren't capable of seeing it. At least I didn't think so. And I started getting jealous of other people observing this comet and reporting that this is going to be a bright one later. I wanted to get in on that. I want to start honing our pipeline so we can make the prediction ourselves as well. And so I decided to reach out to our network and say, hey, I know that we don't think we can observe a comet this faint, but can we try anyway? And somebody did, and it was there. And so this is the picture of that first detection that we had with an EV scope of this comet, which was in April of last year. So a few months after it was discovered and before I thought we'd be able to. And so we learned the capabilities of our EV scopes to detect comets earlier than we thought. So this is at a really faint magnitude that we just didn't think we could see. But now that we know we can start monitoring these comets even sooner, and our predictions can be even better. But yeah, that's the comet right in the middle. It's hard to see, but that's the guy. So what we can do with this information is plot how bright it is over time. So that's what this plot is. All those data points come from different EV scopes. And you could see that cluster is pretty, scattered around. And that's because the comet was really faint there. And so that means you get a lot more scatter, a lot more error in your measurements. And then as the comet got brighter, you can see the dots are more clustered on our prediction line. So we just have a little less scatter as things get easier, as it gets brighter. But this is showing something very exciting, and that is a peak magnitude of around -1. And the projections across the board have been -1, 0, which is very bright. It's easily naked eye. So this is exciting. So it'll be coming to perihelion and closest approach to Earth between September 27th and October 12th. So that'll be the time where this comet's at its brightest. And at this time, there's some good news and bad news. The good news we'll start with is this weird concept called forward scattering. And so basically, this is the idea that the comet is going to be so close to the sun when it's at perihelion that it will be between the Earth and the sun in its orbit. And so we'll get this weird sort of backlit comet. Like if you are driving on the highway and the sun is setting in front of you and you have like a bit of dust on the road, you might notice this effect as well. And what's happening here is that the sun is hitting the dust particles that are in that iconic tail of a comet. And they're doing this weird thing where the particles will scatter the light away when the light hits it, but they preferentially scatter the light forward. And so as the angle gets closer and closer between the Earth and the sun, this effect becomes apparently more obvious. But what happens is the comet is so bright, but the light's being scattered even more, so it looks even brighter. So not only is it going to already be a very obviously naked eye object, it might be even more so. We've seen something like this in the past with Comet McNaught. So that's this picture here, and this is what I showed in the beginning. It might be a good parallel to what we're going to see with C2023A3. But in 2007, this comet showed a lot of forward scattering. So it was predicted to be around -2, which is still brighter than what we predict A3 to be. But it ended up being -5.5 or -6, and that's a lot brighter. And so we can expect something like a maybe 3 to 4 magnitude increase, maybe. Again, comets will do what they want, and we're just gonna have to wait and see how much dust this thing really produces and how it's gonna scatter this light, how much gas it has versus that dust. There's all these factors that could change things, but this just shows that it's going to be brighter than we thought, and it could produce something as beautiful as Comet McNaught did in 2007. Comet McNaught was even seen during the day, so that's what I have circled there during its perihelion time. It's hard to see, but you could see it, which is amazing. The sun is still out. And this kind of gets me into the bad news with A3, is that it is going to be visually close to the sun when it's this bright. So you're going to have to really be chasing it, catching it as the sun is setting or right as the sun is rising, rather than looking at it in the middle of the night, depending on the time. So that's going to make it extra challenging. It's going to make it look a little fainter because the sunlight will kind of block some of the comet light in a way. But, the mix of these two effects, I think it's going to be a worthwhile object to chase and try to find this fall. And then I just wanted to end on what it's looking like now. So this is just a little report that you might get back if you observe with Unistellar. Once you upload your data, we go through an automatic process that just prints out these little reports so we can see what's going on. And this is where I get my data points to put into that light curve I showed you. But so this also shows you a little picture of the target that you're looking at. So right in the center of that little picture is Comet A3. So it's still looking a little bit small, a little bit faint, but it is there and it is brighter. It's an obvious dot in the center of that picture. So that's kind of good news, but it's only going to get brighter. So we're just going to keep monitoring it with the network, and we're going to see what happens in the fall. So yeah, thank you. That's it from me.
Wonderful. Yes, how exciting. I mean, capturing a comet really faint, beyond the limits of the unistellar, or what was thought was the limits of the unistellar is very promising. There's a lot of amateur astronomers that I have talked to about, what kind of citizen science do they do? And sadly, many of them don't get involved in a citizen science program. Um, but Unistellar makes it easy to do, and and the results that you get back are exciting, and you feel like that you're really contributing to science. So it's um, you know I think the perfect accessory for anyone that's thinks that they are a serious amateur.
Yeah, definitely. And I'll also say, just selfishly, as a scientist, I really have been loving having this network of telescopes everywhere. In grad school, I would apply for telescope time and I'd get it sometimes, but
Right.
now I'm getting telescope data every single day, and it's just been really fun to utilize. It's been a lot of data, really, really wonderful. I've been able to do projects I would have never been able to do. So I'm just as grateful for the citizen science aspect
Sure.
as hopefully the citizen scientists are as well.
Oh, I'm sure. I'm sure. Um, Ben Crosswaite is watching, I think, from Australia this morning, or his morning, anyways, on Facebook. And he says he read there's a comet or a meteor coming very close to Earth in 2028. And he said supposedly it will pass under the satellites. And
Ooh.
he says, who's monitoring that? So,
So if
what
it's
do
an
you?
asteroid, that's our planetary defense department. So I'll have to ask that colleague of mine what's
Yeah,
going on in
right,
2028.
right. Yeah. So, uh, Ben, maybe you should get involved in watching that, So,
Yeah, if it's going to do something crazy, I'd love to monitor that and see what happens.
sure, sure. Well, thank you so much again, Ariel, and we look forward to seeing you on again on Global Star Party. Take care.
Yeah, thank you.
Okay. All right. So, up next, we have Robert Reeves to talk about lunar terrain, and I'm very excited to have him come on to the 144th Global Star Party. Let's give the spotlight to you here, Robert. There we go.
Oh, alrighty. Well, in my face. Okay. Uh, well, good thing I took a shower after I worked today, putting up a bunch of siding. Uh,
Hmm.
anyway, the theme of detection. Um, I tried to apply that to the moon. So, how do I interpret that? The detection of finer and finer details, perhaps. What can the amateur astronomer see on some fairly common targets on the moon that um, needs a little bit of extra look? Finding some details on some common targets. So, I'm going to scale my approach to the moon in that direction today. And of course, as usual, saying that if you enjoy what I talk about on the moon, remember there's plenty more where that came from in my book, Exploring the Moon with Robert Reeves, available on Amazon. And just do a title search, Exploring the Moon with Robert Reeves, and there it'll be. It can be on your doorstep in 2 days. So let's try the great screen share experiment and see if my title slide comes up. Do we have postcards from the moon showing?
Yes, you do.
Oh, good. Well, that means we're halfway there. All righty. So today, looking at some of the common objects on the moon. We look up at the full moon and we see the Maria that make the face of the man in the moon, the Mare Imbrium making the left eye, and Serenitatis and Tranquillitatis making the right eye, and various features making the nose and kind of a offset smile. But then you put a telescope on the moon and you start looking at the smaller and smaller details, and the novice sometimes gets lost. I mean, all these details crowding into an eyepiece. It's not like looking at a single galaxy in an eyepiece or a single planet. You've got this crowd of details. So in time, the lunar observer learns to pick and choose and look at specific targets and zero in on particular details on them. So let's move on to the next slide and see the very first one, thinking about um, detecting things that are normally invisible. In this case, we're looking at western Mare Tranquillitatis, just above the Apollo 11 landing area, and we see, excuse me, we see a feature that is normally, pardon me, too much sawdust today. We see a feature that is normally unseen because it only shows up during sunrise shadows, right at sunrise or at sunset. And I'm talking about, moving up one more slide, the ghost crater Lamont. Notice the ringed circular feature surrounded by yet another ring outside of it, and then a number of wrinkle ridges that progress north and south. This gives it the appearance of a lunar spider. But Lamont itself, substantial crater that formed on the Tranquillitatis Basin before the lava flooding that paved it over and turned it into a dark maria. So that crater got buried underneath lava flows, but we can still see where it was by the rim of the crater pushing up the basalt and making these ridges, circular ridges. So we see Lamont in the center, and we notice that there's also a second ring surrounding it, particularly on the south. So nowadays, our interpretation is that Lamont is not just a ghost crater, but a small ghost basin. So we used to think that basins were any crater over 300 kilometers in diameter, but now that definition of a basin is getting flexible. We're finding features smaller than 300 kilometers that have distinctive features of a basin, particularly multiple impact rings. So now Lamont has evolved into a ghost basin. But like I said, you can only see it for maybe 1 or 2 days a month, because after the sunrise shadows, after the sun rises higher, the sunrise shadows go away. And these very shallow ridges that allow us to see Lamont by the sunrise shadows, they're very, very low. They're not more than a couple of 100 meters high. So the shadows disappear. When the sun is overhead, you can't see Lamont at all. It basically vanishes. So moving on to another sneaky little target that you can only see 1 day a month. Now, this is one of the largest mountain ranges on the moon, the Cordillera Mountain Range, which is actually the outer impact ring surrounding Mare Orientale on the far western limb of the moon. We don't see the entirety of Orientale because it overlaps onto the far side of the moon, but we see it just nestled up next to the limb of the moon, and the outer impact rings of it arcing around the near side of the moon form the Cordillera Mountains, which we see here, the mountain range that has the shadow behind them. And then you look up toward the horizon, the limb of the moon, and you see the shadows being cast by yet another mountain range, the Outer Rook Mountains. Well, actually, they're called the Rook Mountains, but we traditionally call them the Outer Rook because right on the horizon we see the sun just kissing the rim of the Inner Rook Mountains. Now, that's an unofficial name. That mountain range, which is the inner impact basin impact ring around Mare Orientale, doesn't have an official name. So we unofficially call it the Inner Rooks, and the Rook Mountains in between that and the Cordilleras, we expand the name a little bit. Instead of calling it just the Rooks, they're the Outer Rooks. But let's get a little bit closer here and look at the Cordilleras. They span hundreds of miles. And here we're looking at the southern part of it. Mare Orientale is on the western limb of the moon, but in order to show it easier on a computer screen, I have turned it sideways. It's flipped over on its side. The west is up in this view, and we see the shadows being cast by the Cordillera range. Now the trick is Let's go to the next slide and we'll see the northern part of them. You still see that shadow casting behind the mountain range, allowing us to see it. Now, bear in mind, up until about 13 days after new moon, the far limb of the moon, western limb, is still in shadow. The phase of the moon hasn't reached that part yet. It's still in darkness. Then about 13 days after new moon, the sunrise reaches the Cordillera and the mountains, and they're casting a shadow, and we can see them, the relief created by the shadows. But one day later, during the full moon, the moon is very flatly illuminated, and we can't see those shadows anymore. The shadows are gone, so the Rook and the Cordilleras disappear. We can see them just that one day a month. So another detailed detection. You can only see it at certain times. So you have to time your approach carefully. About 13 days after new moon, you'll be able to see these. 14 days after new moon, which is technically full moon, they're gone. We can't see them anymore. So moving on to another one. Another thing that happens quickly on the moon, and you gotta keep an eye out for it and watch it as it happens. The span of the span of 4 images of sunrise on Ptolemaeus occurred over a period of only 2 hours. But look at the tremendous change in the appearance of the floor of Ptolemaeus as the sun just kisses it. You see the shadows streaking over from the rim of Ptolemaeus crater. And then as the sun creeps up higher after about 20, 30 minutes, the shadows have noticeably shrunk. Another hour goes by, and now we're seeing most of the floor. And as we approach 2 hours into this sequence, we begin to see features inside the floor of Ptolemaeus crater. We're also observing another curious effect that doesn't last very long, just several hours. So you gotta watch just at sunrise. It's called the clair obscura effect. That's where the bulge of a crater floor, a large crater, bulges up into the sunrise. So we can see the center of the crater being illuminated by the sun before the outer area, the outer portion of the floor of the crater receives sunrise. And this is because the moon is much smaller than the Earth. It's only 2,000 miles in diameter, so the curvature of the moon is much greater than the Earth's curvature. So the bulge of the curvature of the moon protruding up the center of a large crater floor is much more pronounced than it would be on Earth. So we get this effect where the center of the crater sees sunlight first, long before the outer floor receive sunlight, simply because the crater floor is bulged up so much. And again, that effect is called the clair obscura effect. And we can see that on a number of craters on the moon, but it's quite prominent on Ptolemaeus. And Ptolemaeus is almost dead square in the center of the moon. A very popular target during the first quarter moon. So, poking along a little bit here. Another very popular target that has additional details that you should examine, the Aristarchus Plateau up on northern Oceanus Procellarum. We'll kind of zero in on it easily with a modest power eyepiece because the bright ray structure splashed out from Aristarchus crater down in the lower right-hand corner, the southeastern corner of this elevated volcanic plateau. But look carefully around the region, just off to the west of Aristarchus Plateau, we see the ghost crater Prinz partially buried. The southern part of it is completely paved over with Procellarum lavas, only the northern rim of it protruding up. And then above it, notice the pitchfork-shaped rills flowing northward. At the same time, we see Prinz crater is tipped to the south. So, because the southern part of it is buried. So there's a high point right along the northern rim of of a Prinz crater, because those volcanic rills are flowing north. They have to be flowing downhill, and yet Prinz crater is tipped to the south. And in the same region, notice the little mountain peaks protruding up, just up and around the Reimer Prinz complex there. We call those the Harbinger Mountains. And that is simply because when sunlight or sunrise reaches these particular mountains, it is the harbinger of sunrise on the Aristarchus Plateau. So let's zoom in on the plateau a little bit and look at Schroeder's Valley, the hook-shaped rill flowing upward and to the west. This is one of the largest sinuous rills on the moon. This flowed molten lava. Hundreds of cubic kilometers of molten lava flowed down this rill and emptied out onto Oceanus Procellarum, the volcanic fire fountains spraying ash up from the volcanic pit that fed this rill, fed it this molten lava, dusted the entire plateau and gave it a slightly different shade of color than the surrounding Maria. So you look at the Aristarchus Plateau, many people see it as with a very definite yellowish tinge, but it clearly appears darker, even if you're partially colorblind. So lots of interesting features in this area. The plateau itself volcanically elevated and pushed up by the volcanism on the entire region of the of Oceanus Procellarum. And let's sneak up a little further here. More volcanism, but evidence that you can see that there's been relatively recent volcanism on the moon. I've spoken about this before. The volcanic vents on Aristarchus. I mean on Alphonsus crater. Too many A's. Alphonsus crater in this case. The crater immediately south of Ptolemais that we were looking at earlier with the sunrise sequence. But as I've mentioned before, the volcanism of this is very intriguing because we are under the assumption that volcanism on the moon died out about a billion and a half years ago. But here we've got definite pockets of volcanic ash splashed on the moon. Look on the inside of Alphonsus at 9 o'clock, at 3 o'clock, down at 5:30 position, and you can see these dark ash deposits just with a very modest telescope. Now, I am under the theory that ash deposits, dark ash deposits on the moon, will be erased in time, very similar to how crater rays are erased by the ongoing churning of the surface by meteoroid impacts. So we call this the gardening of the surface, where meteorite impacts continuously till the soil and turn it over, and that will eventually erase bright crater rays. On the other hand, it should also erase dark ash deposits. So here we've got these very dark, obvious deposits, indicating something must have happened fairly recently on the moon, volcanically on the moon. So still a bit of a mystery. We haven't seen any active volcanism on the moon recently, but back in 1958, Nikolai Kozyrev took spectrograms of this area and observed a strange spectral response of the area that was convincing enough that back in 1965, NASA sent the Ranger 9 spacecraft to crash land in Alphonsus and look for potential volcanism in the region. Didn't find any. We haven't seen any since. But obviously something has happened in Alphonsus volcanically in the past less than billion years. So looking at other details, features that I really love are floor fractured craters. These are craters that started out like an ordinary complex crater, like Copernicus, for instance, had a central peak, had the collapsed terrace walls that descend down into the crater in a series of stair steps. But if this crater happened to form near a volcanically active maria, the impact shock that shattered the crust underneath the crater provided conduits for subterranean magma chambers to feed lava up to the inside of the crater. So it welled up into the crater floor from within and pushed the crater floor up and paved it over with basalt. And as it pushed it up, it creates these fractures. So Posidonius, we see, is got quite a few rills crisscrossing around it. The western one is particularly intriguing because it's not just fairly straight when you look at it under high power and a really good seeing. It is very squiggly, almost like a coil spring stretched out. So it's a very fascinating feature if you take the time to look at it when the seeing is really good. Another area that deserves attention and examination of finer detail, detecting finer detail, Plateau Crater on the northern shore of Mare Imbrium and the Alpine Valley, stretching across the Alps mountains. Now, when we were kids and just beginning to really enjoy the moon back at the dawn of the space age, the floor of Plato looked flat, black, featureless, and the Alpine Valley was just this scar through the Alps mountains. We did not telescopically see additional detail, but today we look at Plateau Crater, we clearly see multiple small impacts on it. Now, if you can see 4 or 5 of these small impact craters on the floor of Plato, you've got some really good seeing going on. It doesn't take a spectacular telescope to see this, but it does take good seeing. So the image is calm and not quivering. The same with the Alpine Valley. Back in the day, we had no clue that rill ran down the middle of the Alpine Valley. We couldn't see it. We were blind to it. We didn't know it was there. The seeing was usually bad enough that we couldn't resolve it because it's only about 500 meters wide, but it stretches the entire length, more than 100 kilometers of the Alpine Valley. Nowadays, it's become a target to test your seeing and the resolution of your lunar astrophotography. If I don't detect the rill running down the middle of the Alpine Valley, I essentially junk the picture because it's not good enough. Another of the oatmeal cookie craters, as I call them, the floor fractured crater Gassendi on the northern shore of Mare Humorum, another volcanically modified crater. In this case, we can still see some evidences of the terraced walls. We can definitely see the central peak, but the floor of it's been heavily volcanically modified and got these cracks and rills running all over it. Makes it look just like grandma's oatmeal cookie right out of the oven. Another rill that deserves our attention, Rimus ursalis, one of the longest linear rills on the moon, almost 400 kilometers long. Let's zoom in on a little bit, and we can see it south of Oceanus Procellarum, down in the southwestern quadrant of the moon, and a very straight linear rill. It's actually a volcanic feature, a sheet of magma pushed up from the moon's core and thrust up to the crust, through the crust, and split the crust open. But this sheet of magma didn't erupt as a volcanic eruption. So basically, it split the surface open. The land collapsed between 2 parallel faults and created the rill. Now we can trace it up from the south, working up through the north, and see how the rill fractures through pre-existing craters. And then we get up toward the top, and we see those 2 small fresh craters overlaying the rill. So the rill has been there a long time. It cut through pre-existing craters, and then more recently it was overlain by fresher craters. And getting down toward the end of things, look at our one of our sentimental lunar favorites, Tycho crater. Everybody can find Tycho because its magnificent ray system is, I mean, it stretches halfway across the face of the moon during the full moon. But at sunrise, Tycho shows us a different feature. Instead of seeing the ray structure at sunrise, we see thousands and thousands of secondary craters. Let's zoom in a little bit here and look at the region around Tycho. There are thousands of tiny, tiny pits. Now, Tycho formed about 108 million years ago, and that's with an M, not a B. It's fairly new. It formed during the period when the Tyrannosaurus rex was ruling the Earth. The flash that created Tycho surely startled many a T-Rex here on Earth. And as the ejecta showered out of Tycho and rained back down on the moon, it created these secondary craters. There are literally thousands of them all around the Tycho region. Look a little further south, and you can see these secondary craters are spread all over the pre-existing craters that have been there for almost since the moon began was formed. The region around Tycho has craters that are up to 40 times older than Tycho itself. And then here comes the young interloper, creates this blast of buckshot that rains back down on the moon and just peppers the whole region. So one final look here at one of our sentimental lunar favorites, the straight wall, the black linear feature, seen casting a shadow at sunrise. It's a slope, not a classic cliff, but as the sun rises, the steep slope casts a dark shadow. In the afternoon, when the sun is high in the sky, this slope is brightly illuminated and becomes a white line. But what is also visible in this image is something that we were again blind to back in the early days of telescopic lunar observation. We did not know that Rima Burt, that curved linear reel to the sinuous reel to the west of Straight Wall, we didn't even know it was there. We'd look at the moon, it was quivering and shaking, and the seeing was bad, and we were happy to see the Straight Wall, but that Rima Burt eluded us. It didn't become a viable target until the era of digital lunar photography, where we could enhance the view beyond what we could see visually. And now Rima Burt is very much a target that we seek out and verify that our seeing and our focus is good enough. So another one of these targets that we didn't even know about when I first started looking at the moon, and now it's a very common target. Just because we've educated ourselves and gotten much better at knowing what we're looking at. And is that, oops, yeah, I was supposed to zoom in on a little bit and give you a slightly better view of Rima Burt. But if you can imagine looking at the moon through our 4 and 6 inch reflectors that were pretty substantial instruments back in the 1960s. And the atmosphere is quivering and shaking and quivering, and we can't see that Rima Burt, but we could see Straight Wall, so we were happy campers. But it's a whole new world for us now, and I always say there is much to love on the moon, and I always ask you to come out and join me on my playground and enjoy what we see on the moon. And I hope these little clues have given you something to ponder and look a little deeper at the moon, not just at the common target, but the other details that are nearby or even within the target. So there's a world of geology out there, and it's available right in your backyard. The moon laughs at light pollution. So you can observe the moon anytime it's in the sky, even if you're in the big city. So let me stop my screen share, and I have enjoyed speaking to you once again about the subject that I dearly love. It's been a very busy time for me. The Last week I spoke to the local chapter of the American Chemical Society about the moon. Tonight I'm talking to you. Tomorrow I address the Astronomy on Tap chapter here in San Antonio. This Saturday I address the public library.
Oh my
Next week
goodness.
I travel to Corpus Christi and lecture at the Museum of Natural History down there. So I dearly enjoy talking about the moon, and I hope a little bit of my passion for it rubs off on you.
It comes over loud and clear, Robert. It's awesome. So, thank you so much for this presentation, and and for all the hard work you do in making such incredible lunar images. That is they're second to none in my book. So,
Well,
thank you. Thank you
yeah.
for participating on another Global Star Party. You've been on so many at
My
this time,
pleasure.
so we really appreciate it. Okay, all right. So we are going to move along, and our next speaker is Adrian Bradley. Adrian, I think, was mixing bowling and astronomy again. Is that right?
All right, I
Adrian?
found the mute button. So if you were watching my little screen, you probably saw me throw a strike. I am still in bowling league, but I still want to give a quick little presentation. Robert, you're still on. Your presentation inspired me because I'm going to share my phone screen. And let's see, where is the share button? There it is. And I'm going to share some photos. Let's see. Wrong pictures to share. Let me cancel that and share the right app. Now the share screen. That'll work. Okay, so Robert, I pointed my camera. The theme was humility and looking up at the heavens, and it's something that I've always felt was a part of me enjoying the night skies, just looking up at it. And sometimes I also shoot the moon. You say it's in the backyard. Well, this was behind a bowling alley, and I decided to just take a shot at the moon. Did not realize that I ended up capturing the Jura Mountains, which you're seeing in this picture, which I'll try and zoom in. Yeah, the Jura Mountains. I caught a moment that I've heard is known as the Golden Horn, where the Jura Mountains are lit, but the Sea of Rains is still in shadow, the Bay of Rainbows underneath which the Jura Mountains at the top of the picture goes. So this was handheld with a camera, and I know that there are folks who try and get this exact image, and I just simply aimed up and shot it. So sometimes imaging can be, luck or providence, however it plays a role. However, humility also includes there are times when things don't go so well. And that's not one of the pictures. Things may not go well. There could be a lot of haze and a lot of clouds in the sky. We like to show all these beautiful pictures, but we don't show the pictures all the time when we tried to go and clouds interrupted our night, or clouds showed up, or a lot of these are, this picture was an example of I went out there and it was absolutely raining. So humility, not only in looking up and enjoying seeing things you don't normally see, like the upcoming eclipse, but also the humility to know that sometimes, especially if you live in an area like Michigan, clouds are a reality and you just have to deal with it, or do your best to deal with those clouds. And when the moon, like, Robert, all these moon photos, the spirit that Robert Reeves tells us, the moon is always there. And even with a 600 millimeter lens and a decent camera, now these Samsung phones, my thought on it is, if you have a beautiful picture and all of those features are real, it's a real photo. It may not have been captured exactly like my DSLR camera captures it, or like Robert's equipment captures it, but it might be there. So I'm actually going to cut it short because I think it's my turn to bowl again. But I want everyone to know, when you keep looking up, you may get the shot that you intended, but it's far better to get the shot you didn't intend. I didn't intend to get aurora, but I just aimed north and I tried. And when you're on this journey, sometimes it's about the surprises that the universe gives you. And you never know, depending on where you are, what you might uncover. You just have to keep shooting and find out. So with that, I'm going to see if I can unshare, and I'm going to turn the star party back over to you, Scott.
Okay.
And I'll be listening in, of course, muted, but I'll be listening in to the rest of the presentations that are going on. Keep looking up, even if you're bowling. Get
Even
out
if
of the
you're
bowling
bowling.
center,
That's right.
even if you're bowling. Hopefully, when I get back there, I'll throw another strike.
All
But
right.
thank
Sounds
you,
good.
Scott. I always
All
enjoy
right.
being
Good luck
on Global Star Party. Thank you.
and have fun. Thank you. Okay. All right. So now we're going to head on down south to Argentina, where Cesar Bolo is set up on his balcony here. And Cesar, how are you?
How are you?
Good. Good. Let's add you on here to.
It's a clear night. It's great for astronomy. Maybe the first object that we can show live is the classical or your nebula. We can let me show you my screen.
Okay.
We are fighting together something that I need to change the position in my screen is our presentation because it's over. For next time, maybe I need two different screens. Now, perfect. Because sometimes you can see that I move in different positions. More than 1 second. We are in the area. First of all, something that you can see that I change is the time of exposition. I need to use the lower gain and a lower exposition. Now I change it to more gain. For example, tonight I don't have a go-to alienation, but as I have probably much better than another times the position for the polar alignment, I'll put in the nebula now in my screen. Remember the time that I showed the rainbow?
Yes. It's
Okay.
back.
So yes, it's
Oh,
back
wow. Okay.
because because I using, but it's great. It's something that is very near to. It's not the idea to watch to make a picture. If not, first of all, the line here is a reflection because it's a light very near to a building. Actually, the nebula is beside a building, and a reflector in the building make this reflection. But I use an accessory that is not the best for astrophotography because have a little area of reflection. But you can see that I'm using the right, okay, position. For the audience, all that I make is change this position. Okay, this gain and having. We are putting the nebula in the center. Only the idea is watch the nebula with the colors and not in live image and not take the picture. And we are working fastly because in a few minutes more, we are having 6 seconds, okay? And again, it's okay. We are going to have this, a live stack that is perfect for this kind of shows or, you know. And let me clear. Okay. It's the nebula with the rainbows, colors, because it's not the great conditions, it's the city. It's the nebula between 2 buildings with the windows with lights, but as said a few minutes ago, our friend about the lucky that we are to see something. This is great. It's something that
Cesar, if you were doing science imaging,
absolutely
this kind of artifact would not matter. You know, you would ignore the artifact and be looking just for the data, you know, itself. So, but nevertheless, it's still beautiful, and you're doing it. So
yes, you are watching something in your screen that you're taking with your instrument, and in this time you have something at maybe 15,000 years, like years, and 2 buildings between no more than 50 meters. And this is something magic because you are receiving a light from the universe, from many places in the universe. Do remember that, for example, sometimes in another part of the year, in another time of the year, from the same building, I have a time where I can take a galaxy the 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 hot galaxy. And this is magic, and this is not 15,000 years like years. It's much more. It's about millions, and this appears between your city, between the buildings, and it's great. It's something. We can make more. I finish that, and we can make a little more game. Look that something that that is magic. We are watching the how the nebula is going in the backside of the building to have something of a scale. This is a balcony of the building in front of me. Simply is about the scale of the things, and this size is no more. Between this and this, you don't have more diameter than the moon or the sun. The scale of the things are very, very interesting. Look that. We are watching the wheel. We can change it to some southern hemisphere object. I'm going to the Southern Cross. I'm going to put less exposition, more real life exposition, more gain. Look that. It's beautiful. The telescope is tracking the nebula, and it's not the building that is moving. It's you are watching the rotation of our planet. Simply watching a part of the sky with a nebula here. And this is something that is wrong to say, oh, okay, it's a bad picture, okay. But enjoy this moment, sometimes, this kind of moments, and say, come on, it's magic.
Come on, that's right.
Yes, it's absolutely great.
So
this
John Ray is watching on Facebook right now, and he says, he said that amazing circumstances you can overcome and still obtain a good result. Keep going, Caesar.
Thank you.
And he also says, I hope it's not the building moving.
Yes, it's not the wind, that 100 miles per hour wind. Yeah. Let me put to have more idea, let me rotate the CCD. Okay. Because the building is vertical. Okay, to have idea to the audience, what okay. Now, actually, is falling and going to the west, the sky in this part, and falling and going to the west. Let me rotate 180 degrees. It's something that I love. I can rotate that. I don't. Okay, to have the real position of the stars. Now,
I say.
Yes, it's the eclipse of a nebula and wall of a
the Earth
wind.
is turning. Here,
Yes, yes. It's something. All is. Sometimes we feel this like a normal, but it's so great that we can enjoy these single things. Yeah. Now you have the right position. The sky is falling to the west, and you, as my telescope is tracking the moon, is tracking the stars, you are watching the wall of the building, the tower, going to the east and the north on upside. It's
There's
great.
a question here. I know where you are, Cesar, but MG Astronomy watching on YouTube. He says, where about in Argentina are you, Cesar?
In Buenos Aires, the capital city. It's a city of around maybe 15 million people between the city and the metropolitan area. Very, very, very big. Sometimes Maxi tell me that from his city at 200 kilometers, 120 miles, 120 miles, maybe a little more, he can see the bubble of light of Buenos Aires.
Yeah, it's a huge population.
Absolutely. And
Yeah.
a huge
So, yeah,
amount of light pollution, of course.
15,618,000 people
Yes,
this
yes.
year. Mm-hmm.
We can try, I don't know, maybe if I'm lucky, let me try if we can go to another option. Maybe something of, for example, remember the cluster that we saw last week. I found the name, the pair. It's very interesting. The cluster that we found last week. I say the cluster with a shape like a triangle was very interesting, but I don't remember. I don't remember the name. It's the pair, the name of the cluster. Last Friday, we Maxi and Nico, we were together in an observatory of San Miguel. Was a great experience. I prefer next week that we present because we have material. We took pictures. We was so happy to be together in a live person. And was really a nice experience. I tried the area of Eta Carina Nebula. Maybe it's too high for my balcony. Sorry that tonight was I am not in the rooftop. Sometimes for Eta Carina, maybe it's a time that I need maybe wait a little more time. But in the area of Eta Carina, maybe we can find another interesting clouds. Not clouds. Sorry, I don't need clouds. I say clusters. Sorry. We don't need to call to the clouds.
Yeah, that's right.
Well, Karina is beside the roof of my balcony, but let me take a trip by. I can change the declination. Let me show you the telescope. Where is? the light that you are watching is the here.
Here, we got some stars now.
Yes, a lot of stars. It's a very rich area. This is more the area of Vela. Look, the quantity of stars.
Oh, yeah.
I need maybe half hour more if you have more presentations to have clear
Okay.
the Eta Carina nebula. I can
You want
show
to come
you.
back? Yeah,
Yes, yes, no
okay,
problem.
okay.
Because
We can do
it's
that, no
clear.
problem.
It's clear. Maybe in maybe half hour, no more. Well, I prepare another light view of
Mm-hmm.
this area in after some presentations. I
Okay.
enjoying the show and okay,
Thank
I
you. Thank you.
yes, I advise you by WhatsApp when I am ready.
Okay. All right.
Okay,
Okay.
yes.
All right.
Thank you, Scott. We see
Thank you very
you
much,
later.
Cesar.
Yeah,
Okay.
thank you.
Okay. So now we will move across the planet to Nepal to visit with Deepti Gautam. Deepti, are you available?
Hello, Jeff.
There we go. Here we are.
Am I audible?
Yes?
Yeah.
Deepti, it's been a long time since I've seen you. How are you?
I'm good. How are you?
Oh, good. Very good. Is your family
Uh,
fine? Everything good?
yeah, everything is good. Just I'm engaged in my study, and while the GSP is running, I think in the US is like Central Time. It's the PM. It's like
Yes.
nighttime, but in the Nepal it's the early morning, and I
Ah,
have my
okay.
classes early morning.
Oh no. Okay. Mm-hmm.
So luckily, today is some kind of like annual event of our department, and it's going to be a little bit late.
Okay.
So like today, when I see the theme detection, like talking about like as we gather under the like expensive canvas of the night sky, I deeply moved by the theme of detection that premieres our shared passions for astronomy. For me, detection is not just a technical pursuit, it's a profoundly human endeavor that ignites our curiosity, fuels our imagination, and connects us to the vastness of the cosmos. In my journey as an astronomy enthusiast, I have had the privilege of participating in Asteroid Search campaign organized by International Astronomical Search Collaboration, where we search the asteroids. And I have a three provisional discovery searching for these like old space wanderers left over from when our solar system started is really exciting and make you feel small. Like it reminds us to take care of earth and learn about the danger these wandering rocks might bring, but they also have secrets that can help us to understand where we all come from. Like it can demonstrate our origins. But detection isn't just like about the identifying object in the night sky. It's about the delving in the depth of unknown, like peeling back of the layer of mystery that swirl our universe. Whether we are studying the intricate dance of distant galaxies or tracking the trajectory of our near Earth asteroids, its discovery is a testament to human ingenuity and our thirst for knowledge. As we gaze upward, let us not forget that the deeply personal aspect of detection in astronomy. It's about the moment of quiet contemplation as we marvel at the beauty of star. Like it's about the sense of wonders that stirs within us as we like ponder the vastness of space and the nature of our existence. In the stillness of a night sky with a star twinkling like a distant beacons of light, we find ourselves evolved in a profound sense. Whether we are seasoned professional peering through observatory telescopes or enthusiastic amateur gazing from our backyards, the experience unites us in our reverence of the a universe significance or magnificence. Like let us celebrate this theme of detection not just as a scientific pursuit, but as a deeply human endeavors. Let us honor the curiosity that drive us to explore the cosmos and the wonder that binds us to each others and to the star. Like, let us remember that in our quest to detect the mystery of the universe, we are united by our sheer sense, our unwavering belief in the power of discovery. Like while going through the themes, I just remembered something I written a year ago, like about the how I begin my journey and the dream or while I seen while when I slept. Okay, so like I prepare a poem from that story. So I wrote small stories and I converted it into a poem. In the quiet of the night, beneath the starry sky, I stand in the awe of the universe with dreams that fly. As an astrophile, my heart beats for the unknown, with each twinkling star a story to be sung. From the tender age of 9, I gazed up high, dreaming of distant worlds where I could fly. Jupiter, Earth, rockets, and settlement afar ignited with me a passion, a guiding star. Then there was the nightmare, oh so scary. On a rocket with friend, feelings quite worried. We were heading to the space, but things went wrong. Fuel ran out and we could not stay strong. Panic set in as our rocket spun fast, but even in fear, dream hold us steadfast. For from small spark of hope, success can bloom. In the darkest of night, dreams break the gloom. So here's to dreaming, no matter how small. It's what keeps us strong, standing tall. In the twist and turn of life, winding stream, our dream light the way like a guiding beam. Thank you. That's all.
Ah, that's very nice. Yeah, I love that. So wonderful. We miss hearing your poetry, Deep Tea. So
Yeah.
tell us
When I
a,
saw the
tell
email, I saw that short poem, and it was like, oh, I should write the poem.
Yes, that's right.
Yeah.
So how are things going with the NASA group in Nepal?
Okay, NASA is currently like busy in the like Nepal National Astronomy Olympiad, and
Mm-hmm.
International Junior Olympiad is going to held in Nepal. So the preparation is going on to welcome all the like who are from different country to the participants from all the way different countries. And like recently Nepal Astronomical Society in the occasion of like Women and Girls in Astronomy Month, IAU collaboratively celebrate this February 11 is the girls and women in STEM or science, and the March 8 is the Women's Day. And so this month is celebrated as Women and Girls in Astronomy. So recently in March 2, the Nepal Astronomical Society honor and organizes small party type of programs where all these girls and women in astronomy were gathered from the Nepal, and they were honored and they share their journey together. We had a really good time together, and we are engaging in different kind of outreach programs. And recently there is organized K-12 students program in which we organize like different kind of programs for the higher secondary school levels students, like observations. And recently there's a declaration of physics tournament, like a high school physics tournament, which is
Mm-hmm.
going to like organized by Nepal Astronomical Society.
Wow. Okay. It sounds very busy. Sounds
Yeah.
very busy. That's great. That's
Yeah.
great. And how many members now belong to NASA?
So there's a formally total more than 40 member in the for the like associative and other members in core
Mm-hmm.
members, and junior and undergraduate members and other members are likely more than 50 to 60, and there are more of who are engaged as a student and are participating in different programs and helping in this in the outreach programs, and this was the enthusiasm in participating and to be engaged in different kind of outreach programs, which is going to be held in near their locality.
Wonderful, wonderful. Well, that's
Yeah.
great. Okay, so we are going to move on to our next speaker, which will be um, Marcello Souza. But before we go there, I wanted to talk about the April 8th eclipse and where you might be able to go. We've been hearing, well, I've been seeing news stories, I've been hearing personal accounts of people that have made reservations like at hotels, campgrounds, way in advance, where they thought that they were getting a good rate, only to find that this reservation was canceled and due to some crazy, maybe made up excuse. One of them that I heard about on the news was the guy reporting that he had lost his reservation because they had to do sprinkler upgrades in the hotel. Then they come back with, and he had rented the hotel for like about $100 a month, something like that. Um, and not a month, a day, excuse me. And that the new rate afterwards is like 500. And so, unfortunately, there's some of these kinds of things happening. But let me show you an alternative, if you're so inclined. Let's see. I almost never share my screen, guys, so bear with me. Here we go. Here we are. Now this page, this is explorescientific.com/eclipse. And you can see that we have an event here. If you just drop down, this is called Crossroads of the Eclipses Expeditions. Uh, the cost on this particular event is $600, but that's by car, and you can have up to 3 people in the car. So you can use this private campground. It's actually a private ranch, and it's right on the center line in hill country of Texas. So we had a very successful annular eclipse there, and we expect to have another successful total eclipse. But if you're up for camping, whether you got an RV or a tent, you can go to this particular place, and let's see if we have. Yeah, you can see the map of where it is. This is the highway going down to a little town called Lakey, which is down here. So you can see the area. If it was zoomed in, you would see that there's a small airstrip there. And so we expect to have Mickey's Kitchen. Mickey's Kitchen is the same food truck vendor that would attend the Winter Star Party. And so we're really excited to have Mickey's show up for her last hurrah at the Winter Star Party. But Yeah, so that's something that you can check into. David Levy will be speaking at the event. Dina, the former president of the Denver Astronomical Society, will be there speaking, and then we have other speakers as well that will be at on the site there to share the experience with you, but also to be giving some incredible talks. So I'm excited. This will be my fourth total eclipse. And really my first one where I just get to go and enjoy it. You know, normally when I do an eclipse, I'm working during the event. I'll be working this one too, but not to the level that I was for the other eclipses. So I'm looking forward to all of that. But let's go back to Cesar. Cesar, are you? Do you have anything here to show us?
Yes, I think that is going. We can try. We can try
Okay.
because the telescope is pointing. Let me show you to this part of the sky where is.
Oh, I see.
Now this. Okay.
Okay, we got stars.
And we are trying, if we are lucky, to show something in Carina, because the telescope is over Vela, but we are trying to go to the Carina, but Carina is now maybe, let me check. No, no. It's the area that I'm interested in now. It's, but let me try another thing.
Okay. It's a little tricky.
Yes, of course. That Carina is not. Carina is over this part of the roof. No. My God. This is the astronomy from a balcony. Do you have parts and you need to wait the part of the sky that you are interested in?
Yes.
And you know that's, but
it's like the guys used to do, like with the Leviathan telescope with under Parsons. You know, that
yes,
telescope
they
only
had,
leaned up and
oh
down.
my
They had
God, they have
a
over the
little side to
meridian.
side wiggle room, but not
Yeah.
much. You know, so
Yes, yes. And very quickly to show something that maybe you don't have the opportunity to watch something. But
Right.
really, I prefer this that lose the sky. We can try something in the area of the crux. Now I'm going, okay, catalog. We are trying with acrux. Okay.
Got stars again.
Yes, it's another. It's more the acrux area, the crux area. the Southern Cross. This is crazy because, for example, in April, I have this part in the time of the global observatory very clear and very easy to show you. But now it's a mess. And tonight, the problem was that I couldn't go to the rooftop because they are working, renewing the deck, you know. And I say, no, I go to the balcony. But the problem with the balcony is that I have some interesting areas. Of course, that this area is full of stars, but I need to show you more than only stars without the name. Because it's a full
yeah,
area
it's
of
beautiful.
asterism. Yes, you have open clusters.
Mm-hmm.
Very interesting, very full of clusters, an open cluster, and especially asterism like this, like signs, like different names, because the quantity of stars. Well, we continue traveling. Well, if you have some another presentation, I can found something in half hour more. The area is full of stars,
We're waiting for Marcello Souza to finish logging in. So
okay,
it'll be a few minutes here.
Okay, Marcelo is running now because I can.
He's just
after...
logged on. Yeah.
Okay. Well, we are searching open clusters here in this area. We are putting. I'm traveling with the application.
Yes.
Now in a record ascension, I'm going to the south. This is something that I like to make, searching this kind. I like many asterism like this. Look, that it's a perfect C, like Caesar.
Yes.
It's my Caesar asterism. The asterism, of course, that we can tell to the audience that it's an imaginary small form, like a constellation, but to the view at the telescope is an asterism, normally, or binoculars, with the same idea of constellation, an imaginary and shape with the stars. The people call asterism to this kind of shapes. Well, Marcelo is ready. I'm searching something to show to the audience.
Okay.
I come back
Okay.
After Marcelo, no problem.
Sounds
Okay.
good. Okay.
Hi, Marcelo.
Excellent. Okay, so Marcello, let's bring you on.
Hi.
Yeah.
Hi. I'm sorry for the problem here with my
No
computer.
problem.
Everything updated here at the same time, and the Windows updates, and then I had to wait almost 2 hours
For everything to
computed.
update.
Yes. Then I'm almost ready. I need only 2 minutes. It's okay to because I need to open the presentation here to show. And but I can talk here the moment that I'm organizing everything here. I will talk today. First, thank you, Scott, for the invitation. And
Thank you.
again, I apologize for my problems here. But
No problem. No
when the
problem.
computer don't want it to work, I think
Yeah, yeah.
that is difficult.
I do sales too, and so I've when I used to use Windows computers, uh, they're great computers and maybe the best computers for business, but I have had more than once the embarrassment of getting ready to give a presentation and then Windows decides to do an update. You know, it's
Ah,
like, okay, And of course, everybody in the audience understands, but, um, that's the reason why I broadcast using Apple products right now. So,
uh, uh, generally, I don't know why. Even I ask to don't update, but I don't
but
know what to work
it will still update.
update. I don't know why,
Yeah,
but
sure.
I think that everything is ready now. I will
Okay.
try to share my screen. If you work, then I can show. Okay,
Okay.
let me. I will try. On a moment, I put in presentation mode, and I share now. Okay. Okay, I'm sharing my screen. I think that's worked. Can you see?
Yes, I see it.
Ah,
Yep.
okay. Okay. Thank you for the invitation, Scott. Again,
Thank you. Thank you.
it was a great pleasure to be here. I'll talk with something that uh, I am studying now that I don't know if someone already knows about this that we call Miyake events. Uh, It is recent results from 2013 from a Japanese physicist called Miyake. Her surname is Miyake. First, I will show some quick information about the Earth and the magnetic fields, and these are images of our planet. Everything began to change with the contribution of Wagner. The because when you have fossils from Africa and from Brazil, the coast of Brazil, north coast of Brazil, northeast, north coast of Brazil, and part of the coast, Atlantic coast of Africa, some regions of Africa in the Atlantic coast, the fossils in far past are the same. Then they imagine that in one moment these continents were together, and then they begin to move and they separated. But nobody believes in him. And when we had here, you can see that the continents looks like they like a puzzle. No? You can join them, no? The South America and the Africa. Then now we accept this idea, no? After the satellites in the 50s, 1950s. You have now the idea that the past all the continents are together and then they begin to separate, but not the continents as we see. The Earth, they have these regions that are tectonic plates, and the movement of these tectonic plates that is associated with what we have now. But why I'm talking about this? Here we can see the images without the water. This was possible with the radar from the satellites after the 50s, 1950s. Then now we know that we have a Mesoatlantic here border, the separated plates. Here in Brazil, we are safe from earthquakes because we are in the middle of the Atlantic, these Mesoatlantic plates, and you have here regions where the plates, tectonic plates, meet. Then a part where they are moving apart, separate. But why I'm talking about this? I'm not talking about earthquakes, because this is something that's important to understand the magnetic field of the Earth. This is our Earth, the inner parts of Earth. We have an inner core. Sorry, it is in Portuguese. Another after the inner core, we have another core that's fluid. The inner core is solid. Then we have the mantle, and then the crust, and then the atmosphere. You have a hot inner crust, and then this hot inner crust transfer energy to the other layers of the Earth. And as they are fluid layers, they move, have movements, and then the layers interact with the others. You have a friction between the layers, and these frictions, you have ions, that is, you have charged particles, and charged particles in movements, they produce a magnetic field. Then this is the origin of the magnetic field of the Earth. Here you can see the last part of the last layers near the surface. You have the crust, the oceanic crust that is thin, the continental crust, and I don't know how they say in English. I don't know if it's lithosphere and the astronosphere. That are the two layers in the mantle near the crust. This is the movement of the crust. They can separate, they can meet, then can make a movement to separate, but not in Portuguese, cisalhamento. I don't know the correct word in English. You see here in the bottom is what will probably happen in the future with the California. And here's the magma, the movement of magma, the tectonic plates. But I'll go fast now. And this is what causes. They transfer energy and have convection. Here, the hot, like here, I have a model here with water. The hot water is less dense than the cold water. Then the hot water goes up and the cold water goes down. We have a permanent movement in the Earth. If you imagine you have this model, you have a hot core that transfer energy for the mantle, and then the part that begins in contact with the hot core now is hot, they move, is less dense than the others, then go up, and the part that is up is cold, then go down. This movement that produces the movements of tectonic plates and is responsible for the magnetic field. And here you have tsunamis. If you have the meeting of these plates in the ocean, this is one that's happening in Asia. That was a strong one, and causes something like the digital globe saw what's happened. This is an image from Sri Lanka before the tsunami, and the water returned 400 meters, almost 400 meters, 343 meters. Imagine you are near the coast, on the beach, and then you see the water leaving and moving almost 350 kilometers far from you, and then begin to arrive the big wave and destroy everything. And this was a tragedy. A lot of people died before the tsunami. after the tsunami. And then these movements of the tectonic plates cause these kinds of earthquakes and tsunamis that destroy. This was one of the strongest that I saw images. But it's not about this that I would like to talk today. And then now you know the origin of the magnetic field that protects us here on Earth. And you have they protect from mainly from the activity of the sun. You have particles that come from the sun, and the magnetic field, these particles are charged particles, interact with the magnetic fields, and they enter in the Earth atmosphere from the magnetic poles. But some moments you have very strong activities in the sun, like it happened a few weeks ago. And the one that was very strong, the strongest one that was recorded, that was the Carrington event in the 19th century. But this is what protects us. We have inner radiation belt, that is we call also the Van Halen belt, and the outer radiation belt protects us here on Earth from these particles that come from the sun. And what is new? It was discovered in 2013. It was discovered by a Japanese physicist that I already said, Miyake. Here we can see in the trees we have rings. These rings, each ring that we can see here represents 1 year. And you can see that they have different sizes, the rings. And she was studying the rings of the trees, a Japanese tree. And what we already knew, is this. We find an isotope of carbon that is 14 carbon. And this isotope is produced in the upper atmosphere by the incidence of cosmic rays that they interact, they produce neutrons that interact with the nitrogen and produce the carbon-14. Then when we have strong activities in the sun, we have a bigger production of carbon-14 in the upper atmosphere. And this isotope of carbon, we have a register of them in the trees. When we have a big production, we find radioisotopes in the trees. Then she was analyzing a tree. Here is the physicist Miyake, a Japanese. Here an image of the tree that she analyzed, and she saw a register. She found a register of a strong activity, because she found more radioisotopes of carbon-14 than was predicted. Then this is associated with a strong solar activity. The register that she found is an event that happened in 773 years from our time, after Christ, years. Here are the peaks that was found, 774, and she found another one that's 993. And the only one of the explanation of this register that she measured in the tree is probably a strong solar explosion, a strong solar flare that sends had happened a strong coronal mass ejection, and this affected the Earth atmosphere. But this is so strong, and the duration is one of them. They found other events like this. They registered 5 events of this that goes until before Christ, 10,000 years, more or less, a little more than 10,000 years before Christ. And one of the events is so strong that they imagine that it was 10 times stronger than the Carrington event. Then if an event like this happened today, we will have many problems with communication, with the satellites. Then was a very strong event, and they don't know the source of this event because as the duration was a long duration, then they imagine they are trying to understand what can cause. Probably it's something stronger than we imagine that can happen with the sun. They propose that maybe there was some information that about a supernova, but they didn't find registers of a supernova in the period. Then they are yet studying the origin or the source of this kind of events, but they are very strong events, with charged particles, radiation that interact with the Earth atmosphere. And it was discovered in 2013, the first discovery. That is very near. We have 11 years only. And then they are studying and they are find new events like this. Then we don't know what is. Then, and we also don't know when it will happen again. Then something that is we need to more studies about this, and maybe we will find new data about these events. This is something that I would like to share today. That is a curious event, and I have new results, very new results about this. It's something unexpected. Nobody was very waiting that this could be registered. And we are preparing our international meeting in April, at the end of April, 25 and 27 April. Everybody will be very welcome here. I hope you can visit us to participate in these events. And again, I will show the Skies Up magazine, the last edition. That is a fantastic edition. Thank you very much, Scott.
Thank you.
For the
Thank you for
invitation.
your patience and perseverance there, Marcello.
I,
Thank
I
you so
did
much.
I did my best. I hope.
You did very good.
Thank you very much for the
Excellent.
invitation. It's a great pleasure to be here.
Yeah, thank you
Thank
so
you.
much. Thank you. Okay. All right. So we are going back over to Argentina to see what's happening off of Caesar's balcony here.
Yes, yes. And the first option that is in a clear part of the sky going from to the explaining
Yes. Your
explaining
window there. Yes.
let me something that okay. Now, okay. No, was that something of the Zoom control that show me like a month, but I don't know. Well, now this is why the things are appear in this part going, so the rotation of in this part is the south, the things are the rotation of the object in the sky are going in this direction. Okay, this part of the building is the south. Let me like here. Now here, approximately here, is the southern pole in the sky. Okay, we are going first of all to stellarium to show where is a point the telescope. The Eta Carina Nebula is still behind the roof, but we are we can show a cluster that is the Ham cluster, NGC 31 14, and I'll show you where it is. Okay. Now, this part of the sky is going to be shown later because I have the roof of the balcony. But now, actually, this is the direction. The direction is going from the left to the right, and here is where the telescope now is pointing. This is the cluster that we are going to see now in real life, not in a map. Many people ask me if when I show this, this is real. No, this is a map. We are going to see the real image of the cluster. It's an open cluster, really big cluster. Another cluster in the area of Eta Carina is the Wishing Well cluster. Nico took a lot of beautiful pictures of clusters and Eta Carina Nebula, and Agustin is processing now to show the next week the pictures. With my equipment, this equipment, the typical Cesar Brolo balcony equipment, the APO, the APO telescope, apochromic telescope, I'll show you. And the Exus 102 mount. This is my equipment, and it was a pleasure that Nico used my equipment last Friday in San Miguel Observatory, and with his system of many pictures, he took a beautiful pictures of many objects of the southern hemisphere. Well, I'll change my screen to the live view screen. We are going to the same cluster that I showed you, but now the real cluster. Okay, this is, and we can make, let me try. We can center a little better. You can watch my screen of the cluster.
Yes.
Now. Okay. I'm moving the telescope. Look that huge cluster.
Yes.
And we can make this strip that is a live stacking here, because we don't need now Orion Nebula. Okay. The idea is see if we can, okay, we can clear and yeah, let me change this position to make a much better. Let me make less gain, more exposition. We can see 4 seconds, 4 seconds, okay? What we can see if more stars or colors. Beautiful. The first thing that we can see, Scott, is that we are having different colors in the stars. When I change it, yes, to the more exposition and less gain, we are having more control over the colors or the sensitivity of the colors of the camera. This is something. Okay. 4 seconds is okay, and the gain is going to be 200. It's okay, or around 200.
I was just having some memory of shooting astronomical objects on film, and
yes,
every time I see just a few seconds go by and a digital image popping up on the screen of stars or a nebulosity. It's always amazing to me. Even
yes.
more amazing is that you're in Argentina, okay, and we're watching
Yes,
this around the world live. So this is really cool.
yes, yes. We are making this kind of experiment,
Yes.
nice experiment. This is a live stacking, and look of we can have in the cluster increasing the number of objects and the different color of the stars. The more interesting here is that we are having a different color of the stars. If later, if I make how do you say, a process, I can get a very interesting levels of colors and more stars. It's very interesting. It's an open cluster. Trying a little more exposition. Lifestyle. Yes, yes, yes. The good thing is here is increasing more and more. But of course, that is ready to be processed. The things are that that this need to be processed to make, of course, a different level of brights, you know. But it's very interesting. Okay. Here, perfect. We are going to change the gain. It's a great cluster. Very interesting. Well, this is now the best that I can show you because if we go to the Eta Carina Nebula, of course, that is covered by the roof here. It's exactly the Eta Carina Nebula is in this area and the cluster is here. They are going in this position. We are falling. No, they are falling. let me. Um, yes, it's like a circle, like a circular circle.
Mm-hmm.
They're making this is the they are going, yes, little falling back by the line of the roof, and this is the geometry of the sky when you are having the things show watching to the north or south pole that are, for example, you have stars that never are going to the horizon, the circumpolar stars, or for example, the Southern Cross in Buenos Aires. You never watch the Southern Cross under the horizon. Now it's really high in the sky. It's crazy because maybe you are in Florida, United States, and you have the Southern Cross in the best part of the year, exactly over the horizon, and here is over your head. It's very interesting. The geometry of the sky is incredible. Well, I think that maybe I don't know. I'm not sure if let me try if no, it's impossible. It's over the. It's beside the of the bike. And Southern Cross, let me check. Maybe Alpha Centauri, maybe. Rigel Centauri. We are trying. Rigel Centauri. Rigel Ken. Telescope moving. That is very interesting for the audience. Now the telescope is pointing to the southeast, to the well, maybe I'll need a few minutes more to have a part of the sky that is clear. If not, next week, no problem. Every week, yes, every week.
Yeah.
I'll have it more. For example, in April, the same that I trying to show you now, that
Yes.
maybe in 1 hour, maybe in 1 hour, I have cleared this part of.
Okay.
And in April, for example, it's totally clear and it's easy to have Eta Carina Nebula. Something that I prepare for next week too. It's a part in the balcony, more a small, how do you say pedestal in English? I forget the name for the dovetail. The thing that where you have in the observatory, it's like a column, like well, I use a normal tripod and I prepare in the corner of the balcony. I preparing well, it's I can't believe that I forget the name in English totally. It's
It's
in
okay.
Spanish. It's a pedestal. It's a.
I forget the names in English too.
No, yes, but in Spanish too. But well, I prepare una columna to put in the corner of the balcony, and in the corner of the balcony, I'm gain a lot of space, and I don't have problem of the roof. For example, in this part of the balcony here, you have a lot of positions where, for example, Eta Carina in this time of year is have this part of the sky, this view. If I have, let me show you the corner here.
Oh yeah. Then
Well, I am putting here a part, a pier. Pierre. Pierre, is okay? Pierre, yes. A small pier in this part, in the corner, with the EX 100. Yes, I'm gain in this part a lot of space to have more parts in the year, and maybe near to the, not exactly the part of the sky, the horizon, the zenith, but near to the zenith and more of the south, more because when especially the north west is something that I have more space if I put the pier in the corner of the balcony. And this is something that I'm preparing for much better shows and more open sky. But this part of the year is where I have the part of the galaxy very high, and I need that this part is going to make another position where I have the position where, for example, in April, May is excellent because I have Eta Carina or a lot of things that I needed today, but at the same time, I have more options to show. But sorry, Scott, that I don't have more.
No, you
we
took
need
us around the
to
sky.
wait, yes, 2 hours more. No, I'm sorry, it's impossible.
No, it's all good. It was all
okay,
good.
this is astronomy, and this is something that
this is astronomy. Hey, you had clear skies. We got to see stars. Okay, we saw the Orion Nebula. So. And we got to see your setup and everything. So it's always a treat, and it's wonderful to always talk with you, Cesar. So that's great.
Thank you very much, Scott.
Thank you. Okay.
Thank you. Thank you to the audience, and thank you by inviting me.
Yes, thank you so
much. I promise more options next week, and I prepare the pier for the corner of the balcony. Okay. Because we need solutions. We need more options in a night.
That's right.
That's right. Okay. Good night.
All right. Good night, Cesar. Okay. So I just wanted to thank our audience, and I want to thank our presenters. We had a great lineup today. We started the program with David Levy, who was over at Gene Mueller's home. And Gene Mueller is an old friend to many amateur astronomers, including me, and certainly David. Gene is one of the greatest living discoverers of astronomical objects, with over 100 astronomical discoveries under her belt. Tons of supernova, asteroids, and comets. She worked on the Palomar Sky Survey too, on the Schmidt camera up at Palomar Observatory. So you could hear her in the background. She is a little bit shy to be on video, but she was right there. Of course, having poetry recited from memory from David Levy, which is always a treat. John Glass came on next from the Astronomical League to talk about Mercury and how to spot Mercury and stuff. Myself, I've only seen Mercury 3 times with telescopes, but it is a treat to see that little tiny crescent phase that first planet in our solar system. That was followed up with Dr. Ariel Grakowski from the Unistellar Citizen Science program. She was talking about comets, and that's David Levy's favorite subject, of course. If you don't already participate in a citizen science program, there's plenty to choose from right now, and so you might want to get involved. Robert Reeves came on with his postcards from the moon, talking about lunar detections. Adrian Bradley came on for a short time, pausing from bowling strikes at his local bowling alley. So always perseveres and helps us out. Cesar Brolo came on a couple of times here, doing his southern sky balcony astronomy. We went over to Nepal and visited with Deepti Gautam again, who gave us poetry, an update on the Nepal Astronomical Society, and her take on detections in the universe. Marcello Souza was on as well, and always a very interesting subject. This time, Miyake events, which I still need to study up on, but very interesting to have her on. And our audience from around the world, very happy to have you tuning in from the UAE, from London, from Belgium, from all over the world. It's wonderful and really makes Global Star Party truly global. And so that's wonderful. I'm going to finish this program with This Week at NASA. I am a NASA Solar System Ambassador and have been for a long time. This program is part of my NASA Solar System Ambassador project. And you've now watched, if you've watched all the Global Star Parties, you've seen 144 of them. So really want to thank you for tuning in, and as my friend Jack Horkheimer always used to say, keep looking up, and hope you find this This Week at NASA program interesting.
And in asteroid missions close past of the sun. A few of the stories to tell you about This Week at NASA. For the first time in more than 50 years, new NASA science instruments and technology demonstrations have been operated on the moon. A suite of 6 science instruments and tech demos was delivered to the South Pole region of the moon on February 22nd by Intuitive Machines' Odysseus lander. The mission, known as IM-1, was the first successful delivery for the agency's Commercial Lunar Payload Services, or CLPS initiative and Artemis campaign. The Gusto scientific balloon mission is the new record holder for longest flight of any NASA heavy lift, long-duration scientific balloon mission. It recently surpassed the previous record of 55 days, 1 hour, and 34 minutes while flying high above Antarctica. Gusto is an astrophysics mission that is mapping a large part of the Milky Way galaxy, including the galactic center and the nearby Large Magellanic Cloud. Preliminary telemetry indicates that our OSIRIS-APEX spacecraft, formerly known as OSIRIS-REx, recently completed an operation that brought it 25 million miles closer to the Sun than it was designed to function. The close pass of the Sun, or perihelion, was the first of 7 the spacecraft will make on its journey to study asteroid Apophis, which is expected to have a rare close encounter with Earth in April 2029. The recent carpet determination in entirety measurements, or carpet diem tests, were aimed at helping researchers examine the quality and ruggedness of a new generation of ground recording systems. The recording equipment is needed for future flight tests of our experimental X-59 aircraft to confirm that it can fly supersonic while producing just a quiet sonic thump. The X-59 is not yet flying, so an F-15 and an F-18 aircraft were used to make supersonic passes for the recording equipment. That's what's up this week at NASA. For more about what else we're up to, check out nasa.gov.